was highly informative, sir, especially step-by-step process and explanations for factor analysis was excellent, sir. We got feedback from all the participants, attendees, sir.
Very good, madam. Very good. In fact, a cluster is easy. I think they have tired because we have taken up little late. So cluster is very easy. Only one step.
Yes, sir.
But only one step. More than factor, cluster is more useful, madam.
Correct,
Highly
sir.
useful.
Yes, sir. We will wait for one more 2 to 3 minutes to start the session, sir.
No, we'll start, madam. We'll start.
Okay, sir. Lokeshwari, we can start.
Yes, ma'am. Vishnupriya?
Yes, ma'am. Never stop learning because life never stops teaching. A pleasant evening to everyone. Myself, Vishnupriya M., first year MBA, take immense pleasure in welcoming you all virtually to this 5 days faculty development program themed Emerging Research Trends in Management. The main idea behind this development program is to help resource people, faculties, and others to strengthen, upgrade, and enhance their teaching and research skills in the area of management. I sincerely welcome our beloved Director Ma'am, Dr. U. Amaleshwari, our faculty members, and all the registered participants to this 4th day of Faculty Development Program of DDGD Vaishnav School of Management. The research title for the day is Factor Analysis, EFA and CFA, Advanced SEM with AMOS by our beloved resource person, Dr. Kasilingam. Your previous session regarding factor and cluster analysis was very informative, sir. And we look forward to hear more from you from today's session. Thank you, sir.
Okay. Thank you, madam. Thank you. So, I think, shall I proceed, madam?
Yes, sir. Yes.
Okay, fine. Now, okay. So now, good afternoon, my dear friends. So, thank you very much for Amaleshwari madam and others for giving the opportunity to take second day also. Right. So, let me start from where we have left the other day. So, other day we have discussed about the factor cluster. Right. So, I hope you might have understood the factor. In the factor, we have, so people used to discuss both things simultaneously, but normally I will not do that. But even then, okay, since the madam has asked me, I will take, because for EFA we will use one software, for CFA we will use another software. But even then, let me tell in a different format, no issue. Now, in the EFA, we have given 19 statements. Madam, I'm audible, madam? Lokeshwari, madam?
Yes, sir.
Yeah.
Yes, sir, you're audible, sir.
Right. In the EFA, that is exploratory, exploring, discovering, finding out. Finding out factors from overall, right? Overall 19 statements, whether there are some groups are there. That is what EFA. Now, exploring factor. Now, CFA is confirming the factor. What do you mean by confirming the factors? For example, if you look at this screen, in the screen, you can see there is one heading by name supply chain concern. There is another heading by name supply chain competence. There is another heading by name supply chain performance. Right. Which means in the questionnaire itself, we have grouped the items, right? So these 5 are related to supply chain concern. Another 4 related to competence. Another 3, these 3 related to performance. So in the questionnaire itself, we have classified, which means identified in the questionnaire itself. Under each factor, we have given some items. So the factors are identified already, which you have displayed in your questionnaire. You have collected the data. Now you are confirming whatever you have done is right or wrong. You have put supply chain concern under which this 5. Why you have put this 5? Because you feel these 5 are related to supply chain concern. These 4 are related to supply chain competence. These 3 are related to supply chain performance. Now you are confirming, is it? Now after collecting data, now you are confirming, is it same? What you have identified? What you have identified is right or wrong. That is what we are doing now. That is the CFA. That is CFA. Okay, so now this is very essential, very essential. Everybody should do, because you are validating the questionnaire. Whatever you have done is right or wrong. Unless otherwise your questionnaire construction is right, your finding cannot be right. So this is very vital. Everybody should do. Everybody should do. All other analysis, if you are interested, if it is required, you can do. But this is very vital. Everybody should do. You cannot ignore. This is, otherwise we call it as reliability and validity checking. So now what happened when I have studied MBA, where I have studied research methodology, that time we never had these things. But when I become the teacher, right, when I was working in St. Joseph College, the people who are taking this research methodology paper, they were discussing validity, reliability, all these things. We thought we have now discussed. Then we have brought one faculty that, okay, so Ranganathan sir, to take lecture so that we will understand. Then even then we could not understand much. Then there is a big story how we have learned first. There is a very big story how we have learned. Now everybody doing, everybody it is available. Okay, but what I am trying to tell, it is very important. That is the point which you need to understand. Right. So now let me perform this one with like a factor analysis. Then I will go to the another software. Right. First. Right. So now let me show one questionnaire. See, this is the some okay, some model, right? Some model. This is the model, right? So now before preparing questionnaire, you need to have conceptual model, right? So without conceptual model, you should not go for it. This is a conceptual model. So let me take instead of taking all these things, let me take this 4. So now emotional intelligence, work environment, work-life balance, and employee attribution, right? So these are all the 4 constructs. Under each construct, we have put around 4 or 5 items, right? So now let me show the questionnaire also. So that is the model, right? Now let me go through the questionnaire. Right. So now statement is not given. Sorry. Okay. So for example, right, we have work environment under which we have put 4 statements, and we have 5 statements. Emotional intelligence 5 statements. So like that, we have put what are the statements only here. Not put to the entire questionnaire. So like that we have, right. So now you can see EATI means employee attrition and retention. So WOLP means work-life balance. So this is emotional intelligence ETIC. Like that we have, right. So now let me run a factor analysis for this. Let me run a factor analysis for this one, right. So now analyze, right. We know that dimension reduction, right. Factor, all I have placed, WI, all these statements, Though in the questionnaire, I have put for each construct that we call it as construct, all right, one heading that we call it as a construct. Otherwise, we call it as factor. Otherwise, we call it as domain, dimensions, or same word, same meaning. Right? Factor, construct, domain, dimension. Right. So now I have taken around 4 dimensions, under each dimensions around 5 statements are there. Now, though in the questionnaire I have put separately, now I have mixed, I have put everything together. Right. So now let me run, right, descriptive statistics, right, let me run descriptive KMO, continue. Then extraction, right, all eigenvalue greater than 1, fine, right. So now a rotation, right, very max rotation, right. Then okay, options, right. So sorted by size, suppress, greater than 0.5, less than 0.5 means suppress, right. So these are all we know, right. Whatever we have discussed, I am doing it again, right. So now if I in now, okay, now if you go and see, okay, so I have put 4 factors, right. I have put 4 factors. Now it is also divided into 4 factors. In the questionnaire, I have had a 4, but now I have mixed everything together. Now I am asking the system to identify the factors. Now it says there are 4 factors, right. That is number 1. Number 2, now you look at these, okay, so look at, see, all WE5, 1, 2, 3, 4, 5, all are 1. So all WLP, okay, all WLP is all 1. All, okay, so all EI is 1. All AI is 1. Right. Now, what does it mean? I have done an exploratory analysis, right? I have done an exploratory analysis. By putting all, it says, okay, so it can be divided into 4, right? The grouping also, okay, so as per what is available in the questionnaire, right? Which means, which is confirming whatever we have done is right. So now look at the all other things, right? So look at the KMO. KMO should be more than 0.6. Look at 0.935, right? Look at the all commonalities. Each statements are greater than 0.5. Or look at all. All statement, all commonality is very great. Then number of factors also 4. Right? So now this also right. So which means it is confirming, right? So through exploratory factor analysis, we are confirming whatever we have done is right. Whatever we have done is right. All right. So now, how when we look at the each item loading, look at the each item loading, all are greater than 0.5, which means each item is loaded properly. Right. So this is the one. This is the one. Right. Right. So through EFA, we can confirm whatever we have done is right. So this is we are doing now. You perform anything, right? You perform any test. For example, right? All the people they will perform Cronbach alpha. So let me perform Cronbach alpha also here, right? Cronbach alpha, scale, reliability, right? So Cronbach alpha we have to perform for each variable, right? Each construct separately. So now look at WPS. Okay, let me perform WPS WE. WE. Okay, WE1, WE2. Right. So now, right. So now, okay, look at Cronbach alpha, right? 0.970. It should be more than 0.7. Okay, fantastic. Then look at the, okay, in the Cronbach alpha itself, right? So statistics, scale if item deleted. Scale if item deleted, right? Statistics and so now, right, it says, right, already my Cronbach alpha value is 0.970. So here also, if I remove this one, it says it can increase, but it will not increase much. So need not be increased, need not be deleted, need not be deleted. So you can keep as it is. Right? So like that, it is confirming whatever we want to have. Right. So now let me perform, okay, from here itself, straight away I can go to the AMOS, right? There is I have pattern matrix builder, but somehow it is not. It is hanged. It is not working. Okay, you can keep us right? Okay, so like that now. Okay, so let me do. Right. See, I'm going to. Okay, so what I'm going to do is right. Okay, so whatever we have done, right? தம்பி யாருப்பா Okay, leave it. Okay, so now, okay, so now I will draw quickly, okay, so that you'll understand, right? So already I thought I have drawn. All right. So now, okay, so let me draw quickly. So each 5, right? 1, 2, 3, 5. So I have taken this one, right? I have taken this one, right? So let me, okay, so right here, 1, 2. So 1, 2, 3, 4, 5. I'm just drawing, right? Okay. So now I've drawn, but okay. So now I have to rotate. So how to rotate? Why I'm rotating? Because I want to draw like this. I want to draw like this. I want to draw like this. Okay. So that is why I'm doing, right. I want to do. So now, okay. Okay, so now I'm rotating. How I'm rotating, right? So that is fine. Next, I'm moving, right? So I'm moving like this. I'm moving, right? So next is I'm moving, right? Yes, so that one like this. Okay, so say still, okay. I want to review interface property, right? I'm increasing the this. Portrait legal. Okay, so that it will be legal. Okay, so now I'm moving, right? I'm moving, right? So I have sufficient space. All right. So now listen what I'm doing, right? Okay. So I've drawn. So this is the okay four factor, right? Next, mm, I have to this okay relationship, right? So relationship. Okay, so this is the relation. Double-edged arrow is talking about the relationship, right? So now this is for making it more attractive. So touch to, so that we can make touches here and there to make it attractive. This is a touch to. Okay. So now I have drawn, right? Now the first step we have to draw, right? Drawing is important here. So next is let me connect the this because I'm in the AMOS, my data is in SPSS. So let me connect with that. Okay, so I need not import. I need not import. Uh, I need not import. That is the story because this software as well as SPSS software from the same company. So straight away I can link. Straight away I can link. So this is linked with the data. Now this should be mapped. Okay. So I'm mapping. So list of variable in the data set. So it will give. Okay. So now let me take. So now I'm taking and putting on that. Okay. So that is what I'm doing. Right. So now. Yeah. Right, AI to that is I have wrongly placed. Yes. So the I'm using scissor to cut, right, because I have wrongly placed it. If you are wrongly placed in some other okay, then if you place the new one, automatically it will go. Automatically it will. So this is AMOS. I am doing a analysis of moment structure, right? Right. So this is done. This is done. Right. So I have connected. Now let me give a name to the factors. Right. So that is called WE. Right. So this is called EI. EI. So this is called work balance. So this is called AI. Right. This is called AI. Right. All names are done. Now these errors, all the errors should be named, for which instead of giving one by one, let me use name unobserved variable. This is unobserved variable, right? Unobserved variable. Now, if you want to make this big, that also you can do, right? For example, if you do, right, whatever size you want to have, right, that also you can do, whatever size you have. Right. Okay, so that is also done. That is also done. So all now what I have done. Okay, so I have drawn second step, linking the data. Okay, then mapping with items, right, and items with the data, right. So now the analyze property. In the analyze property, okay, in the estimate, we need to have standardized one and we need to have correlation. We need to have correlation, right? So now if you do, okay, so now that's all matter over, right? Okay, so now estimate, calculate estimates, right? It is asking it to save. Let me save in the desktop. Let me save in the desktop, right? So let me put CFA. Okay, CFA2. Let me put sorry, CFA2. Right. So now it is right. Now, okay. So I have now I have now right. See, earlier that also I will show. That also I will show. Now what happened in the almost 21 and other thing here itself, right? This drawing also not necessary. Straight away from the okay that rotated matrix, I can put it in the pattern matrix. That also I have. Oh, sorry. Okay. So I open in the 20, right? Okay. Okay. So then first I will do in, okay, start tool pack. Then I will open in that and I will do. Okay. Now this is the estimates. This is the estimates. Now I will go to the Excel. I will go to the Excel. That is a start tool pack, right? Start tool pack. Okay, so I'm going to the Excel. That is the stat tool pack, right? That is available in the Excel, right? So I'm opening. So validity master, right? Validity master. Now, if you read this one, okay, you need not remember. Paste the correlation table into A1, right? So let me paste the correlation table right here. Here I have yeah, right here I have correlation table. So you can see correlation table, right? This table. So let me copy. Let me paste the correlation table here. Correlation table. Then A1 I have done. Then standardized regression weight table in F1. So what I'm doing is I'm going there, right? So standardized regression weight. So this is the standardized regression weight. So I'm okay. So copy, right, right. So let me go here F1, right? Now done, right. So now let me then click F1, right? Okay, then click me, right? So now let me click, right? So now we can see. So no validity concern. Wow, this is the result you should get. So which means that we do not have any problem in the questionnaire. The validity of the questionnaire is good. So earlier also when see we have done that CFA we have confirmed through EFA. Now this is Pakka CFA. Otherwise we call it as measurement model. By using this also we are confirming, right? So what is this values? What is this one that you need to understand, right? So now what to do? Now what to do? This is one, right? Earlier we see in the beginning. Okay, so we have calculated all these values by using the formula, right? So first initial stages we have calculated. Then after some time, that James Caskin, so he has given this Excel tool pack, right? Then we were using. Now what happened? So now it is available in the plugin itself. Now let me go to the plugin. Right. So now let me open, not this one. Let me open. So I put same. Okay, whatever I have done, right? In the desktop, right? We have put CFA. This is the one, right? Okay. So let me open here. Hi. So now let me close this one, right? So it says already I'm using this, right? Let me close this. Right. So now here, okay. So now analyze. Okay. So calculate estimates. All already we have done all. Okay. So we are just opening here. Right. All it is there. Right. So now. Right. So now here, okay. So the result will come. So plugin. If you go to plugin, right here, master validity, right? So master validity here. If I check the master validity, here itself it will come. Here itself, right? Now we can see, right? All CR value, AV value, MSC value, all this value, and it says no validity concern, right? So now it is available here itself. What is the book you have to follow, right? Pendler, okay. So all these things it is given. So again, it is given by Caskin, right? Caskin. So you can use this also. Now it is available in the along with the software itself as a plugin, right? You can use. Now, okay. Now I'm going to explain what is this CR values, what is this, okay. So how it is calculated, all the formula, it is given in the PPT, all the formula, right? You have to understand the formula, then only you can understand how it is performed, all these things. Okay, so whatever I am telling is right or wrong, only when you understand how I have calculated. See here, by using this formula, I have calculated and I have shown, right? But that much let me not tell now. Whenever I take this AMOS as a separate workshop, then I used to teach how each is calculated, right? How all values are coming, that also I will tell. But let me not tell now. Now, what is this AVE and CR values, right? So now there are some validity. One is called the construct validity, right? Construct validity. Now, what is the construct validity? Now, we have a construct, right? What here emotional intelligence is our own construct. Then in the previous example, supply chain concern is our own construct. So one heading, one factor, under which we have put some items, right? So now we want to show whether the construct is valid, reliable, right? When we can call construct is reliable or valid, which means when we have measured the construct properly or sufficiently, let me put the word sufficiently, right? So we have one heading. So some people they will put only 2, only 3, only 4, right? So when you put only 2, you may not measure that sufficiently. So your total measurement, right? Total measurement will not be sufficient, right? So see whether we are sufficiently measuring, right? So that is why the CR value we are adding all, or we are adding all, right? Adding all loading divided by loading plus not measured. So measured divided by measured and not measured. So when it is more than 0.7, then we will say construct is reliable. So when CR is more than 0.7, we will say construct is reliable. Now if you look at this one, so look at all CR values are 0.9. So definitely more than 0.7. Right. So which means we are measuring properly. We are measuring properly. Construct is reliable. So even if it is measured by somebody else, if it is used again also, it will produce the same result. Right. That is the point number 1. That is CR. Right. Then, right now, under each, right, construct, we have used 4 statements and 5 statements. Right. So whatever we have used is okay. So all items are related. Okay. Otherwise the convergent validity. Convergent validity means whether all items are converging properly, whether all items are related properly. Right. So that is called the convergent validity. That is measured through AVE. Now, AVE should be more than 0.5. AVE should be more than 0.5. Here, all are 0.8. So, one more thing you need to understand, the AVE value should not be greater than CR value. Right? AVE value should not be more than CR values. Right? So, now first one, whether we are measuring properly, whether all items, see, we have formative construct and the reflective construct. All our constructs are reflective constructs. So which means all items are related. So here we are trying to ensure all our items are related to each other, which means it are closely converging each other. Right? That is called the convergent validity. So convergent validity is measured through AVE. AVE means average variance extracted. So this is CR means composite reliability. Then we have another validity called divergent validity. What is divergent validity? Now we have used okay, here we have used 4 construct, right? B, W, E, I, WLP, all. See, we have used 4 construct, right? As I have told you in the factor analysis, right? Now all the factors should not be related, right? All the factors should not be related, right? What does it mean? That is why, okay, each item, each construct is separate. If construct are same, why we need to have different construct? So this construct is different, that construct is different. How do you say that construct is different? Which means relationship between the construct is not very much there. So, but we cannot say that there will not be any correlation. There will be some correlation, right? There will be some correlation, but the correlation should be less than the AVE, right? So for every constraint, right? For every constraint we have AVE. Every constraint there we have AVE, right? Every constraint. So now these diagonal values are the AVE is square root. So please understand. So this is point. So when you put a square value, will get reduced. So now see this 0.878 square root is 0.937. So that is why WE here also WE, right? See here WE. So now if you look at this one, EI. So what is this 0.908? 908 is nothing but the square root of this one. 0.921 square root of this one. Okay. Now all these diagonal values are greater than the other values. Look at this one. This value is greater than this. Look at this one. This is greater than this one and greater than this one. This one greater than this one, greater than. So which means this square root of ABE is greater than the relation, right? So now if you look at this, what is this? Okay, I've closed this one. So now every item is related. But when we look at, okay, so now let me see, let me use this magnifying glass. So now you see here, right? This is the relation between WE and the EI, right? So 0.33, right? Okay, WE, EI. So now you can see here, right? See WE, EI. So you can see that values, whatever values we have, right? WL. So like that, what is the relationship between each? So that is these values. So these values are AV values are greater than, which means that is there is a divergent validity. What do you mean by divergent validity? The factors are diverge, different, right? Different. So which means the items are not cross loading. Items, okay, it might cross load, but the cross loading is not. What do you mean by cross load? One item will load here also, one item will load other also. When there is a cross loading is there, then definitely there will be a correlation. Because this item is loaded here, there also, then there will be relationship between two concepts also. So now, right, see, there are some 4 validity. Okay, first one is item validity. Item validity is measured. Okay, we want to measure each item is valid or not, right? You can see here. Look at all these loading values, right? Let me put to the standardized. So all the values, loading values, should be greater than 0.5. Okay, if it is greater than 0.7, it is pakka. All values are greater. See here, all loadings are greater. Right, so that is called each item is valid. Each item is valid. Then okay, construct reliability. Each construct is reliable. Then items are related to each other. Convergent validity. Okay, that is also there. Then divergent validity. This is different from this, right? So when you perform all these things, right, then you are checking the validity perfectly, right? So this is called the CFA. Confirmatory factor analysis, right? Whatever we have done is right or wrong, we are measuring, right? So when it is like this, our questionnaire is valid, whatever we have done is valid. So whatever analysis you do based on this one, it is valid, right? So this is called the confirmatory factor analysis. Otherwise, we call it as a measurement model in AMOS, right? In AMOS, we have 2 models. One is called measurement model, another is called path analysis. Both put together, we call it as SAM. Right? So this is one. So I used through here model checking, put there also, right? Okay. So now, if you have any question, you can ask me now. Yes, any question? Any question, madam?
No, sir. Actually, you can proceed, sir.
Sir, can I ask you a small clarification, sir?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Sir, when you are going from factor analysis to AMOS, the step which you used to enter into this, can you just show that once again, please?
No, no. Tell again, sir.
When you went from factor analysis to AMOS, the first step in this, when you opened AMOS, how to enter into AMOS with, that is the beginning, first step.
No, no, sir. I don't understand your question, but let me tell again, sir. Okay. So now, okay. So, okay. So, okay.
In this AMOS,
Yes,
when
sir.
you, sorry, sir.
Wait, sir. Wait, sir. Now, I have a data in SPSS, sir. I have a data in SPSS, right? Yes or no? This is the data,
Okay, sir.
right?
Okay.
So now, if you have entered data in Excel, that also can be uploaded here in SPSS. Now, if you have in data in SPSS, right? Let us assume that you have a data in SPSS, right? Okay. So now தம்பி அதை போட்டு விட்டுருப்பா போய் குறைஞ்சி போச்சு எஸ் டக்குன்னு போயிடும் ஓகே ஸோ நவ் so this is 20 version, sir, right? This is 20 version where I will not be having plugins, right? And now let me close all. Let me close all, sir. So now I am opening the AMOS. This is the AMOS graph. Okay, file, right? New file, right? It will be like this, sir, right? It will be like this, right? Pakka. So now here, first step is drawing. First step is drawing, right? Now I know that I have 4 constructs. I have 4 constructs, right? What do you mean by construct? The factor heading, right? 4 heading. Under each heading, I have 5 statements or item, right? So I have to draw here, right? So now to draw construct or latent variable. Construct is also called a latent variable. Because why construct is called a latent variable? Now, if you look at this, right? If you look at this one, this is a construct. Supply chain concern is a construct. These are all items. Now we have collected a data only for items. We do not have data for this construct. We derive value for this one based on these items. That is why it is called construct. Constructed through items. Constructed through items, right? So now I want to construct, right? Constructed. So now since I do not have data directly, that is why called latent, hidden. It is hidden. Value will come, but not directly. So that is why we call it as a latent variable. Now this is my latent variable, but having 5 items. So this is a different example. Now whatever example I am taking is okay, because here, right, I will get to the Pakka result. That is why I am taking this one, right? So now, okay. So now I am going to draw. Now, if you look at here, right, you can watch. Draw latent variable. Draw latent variable. Draw latent variable with the indicators. Indicator means item, right? For latent variable, there are many names. What are the names? Factor, dimension, domain, construct. Like they say, for each item, we call it a statement or item or indicators, indicating, indicating. So that is why that is called indicator. You click this one, right? Now you click it, it will come, right? If you click one more time, it will come, right? So I need to have 5. So here also 5, here also 5, right? So here also 5, right? Also 5, right? I have a 4 with the 5 items, right? So now this is over. So now I have to rotate. So if I want to rotate one item, then I can do just like that. I want to rotate the entire object. So I have to use this one. That is a preserve symmetry. Click it. Then rotate. Here I am using, see here, rotate. Rotate, right? So I have rotated, right? I have rotated, right? I am rotating. So here also I am rotating. Here also I am rotating, right? So here also I am rotating, right? Okay. Since I feel that I do not have sufficient space, so I have to draw. Please, that you should understand. You have to draw everything in this within this white panel. Everything within this white panel. So what I have to do is, since I overloaded one above there, let me change the shape of this drawing. So for which view, interface property, page layout, right? Here portrait letter I have. So let me use portrait legal, right? Portrait legal, apply, then it will be like this. So it will be like this. So I will get a, okay. So now since it is outside, let me push it, right? So let me use the moving the object by using the lorry. So I'm moving, right? Here I am bringing. So here I am bringing, right? Here I am bringing, right? So now here, okay. So here, right? Here, right? Okay, fine. Now done. So now I have drawn, right? I will see. I need to capture this. This will capture the loading. This will capture the loading. So I have to capture the relationship, right? Because I need a relationship, right? Because this I want to know whether this construct, whether it is related with the other construct. I had stated that it should not have much relationship, right? Otherwise, relationship should be less. So I'm drawing, right? I'm drawing. Right? To capture that, I'm drawing, right? Okay, fine. So now what I'm doing is, since I am not drawn properly, so I'm using this touch tool to make attraction, right? To bring the attraction, touching, right? Let me use this one, right? Touch tool I've done, right? So touch tool I've done. So now I've drawn the diagram. I've drawn the diagram, right? Now I have a diagram, data in spaces. Now I have to link. I have to link, right? Let me link by using this Excel. You can see select data files. Select data files. Now it's here. Select, right? File name, right? Wherever you have. Okay. Say okay. Now I have to say okay. That is very, very important. No, I've linked. I've linked. But here, see, I should get a WE here. I should get work-life balance here. So I should get like that, right? Okay. So I should link. I should link with that particular item. So this item should capture that, right? That is what I'm doing. Now, if you go here, list of variables in the data set. So it will show now since the data set is linked there, all the data it will come here. So now all the data is here. So now I am placing. How I am placing, right? Let me go here, right? So I'm taking clicked. Okay. So now I'm linking. I'm placing it here, right? Okay. So now like that, I'm placing it here, right? I'm placing it Yeah, right. So now you can see, click. Now if I carry, you can see I'm carrying, right? So you have to put in this dimension, right? That rectangle. So rectangle, right? So like that, I'm placing in the rectangle, right? So now let me do fast. Let me do fast, right? So like that. Now all the data, see now here that data will come, that item. So here that item will come. Now since see, since it is so this one, I'm changing by using change the shape of the object, right? So that I'm doing. So now I'm changing here, so that whatever size you want, whatever size, all okay, you can change the shape, okay, whatever size you want. So to make okay, so it should be attractive, right? It should be attractive, whatever change you want, okay, you can, right, done. So now okay, so now here this is about we, so let me say this is we, right? So we, right click object property, let me do it again, right? So right click object property, right click object properties. So emotional intelligence, so this now I can click here, that will come work life balance. So this is AI attrition rate. Okay. So now here also all should be named. So for which right click I can put E1, E2. But what I can do is plug in, right, name unobserved variable, right? So here you need to understand one thing. So this dimension, right, the rectangle is a observed variable for which we have data. So all these things are raw. Circle is a latent variable, unobserved variable. So this also unobserved, this also unobserved. Now presently unobserved. So value will come from here later. Now no. So this is also circle. So this is called unobserved variable, or okay. So which will capture the error. So name the unobserved variable, right? All error. So this will load into here. Remaining will be captured here, right? So it will load here. Remaining is captured in the error. Okay, so now I have done, right, in the analyze property. So in the output I want to have standardized, because I'm using the standardized, I'm using the correlation, right? Let me click done, right? So now I have done all, right? So now okay, now calculate estimates. So these three are very, very important. One is selecting the data, another is changing the see here, whenever we perform analysis, we might be interested to get more and more information in the output. So whatever you want to have, you have to click here, right? There you so much you can get what you want, right? Here we have so much, here we have so much okay, so now calculate estimates, let me click this, I'm calculating, right? So already now let me save this as CFA 3, CFA 3, okay, because already I have one value new. Okay, now it is okay. Now if I click earlier it will not be there. Now successfully executed, now it is coming, right? Okay, so now okay, so you have to copy this one and you have to paste it. So for which you have to use select all. This is select only one. If you use this one, select all. Okay. all will become. Now if you put control C and control V, you can paste it, right? Now you see. All right. So all the values, all it will come here. So you can see the values, right? All values, right? What is the values? All you can see, right? So now you can see the relationship is less. Relationship is 40, 30, 27, like that only. But the loadings are very, very, very attractive. Now, okay, if you want to see, okay, if you want to, so this is the unstandardized. If you put to the standardized, all standardized values will come. Now you can go and see this one. So now all my values are greater than zero point 0.5. So if it is more than 0.7, it is good. But even if it is more than 0.5, it is okay, because some other items will be more, right? We want to have overall, it should be more than the 0.5. Overall, it should be. So now all, see here, 91, 90, 0.91, all are fantastic values. Fantastic values. So now, okay, so now that is one. So now unselect, right? Me unselect. Select. So now, okay. So now here, so I know how to take it there, right? You know how to take it there. Okay, go to that Excel tool pack. Here it is there. Right, let me draw that also. Right, let me draw that. So now, okay, this is the one freely available, right? A start tool pack. Okay, you can see here, start tool package, right? If you click here, it is telling paste the correlation, right? So now let me paste the correlation, right? So here I'm going to the view text. So view textual output, that is the diagrammatic output. This is the textual output. So view to the textual output. Now let me click the correlation. Let me click this correlation, right? Select, right? I pasted the correlation, right? I pasted this. Sorry, yeah. Okay, so I'm not selected that. Copy. So here, right, one done. So next is standardized regression weight. This is my standardized regression weight. Copy. Right. Go here. Right. So now let me click here. You should get this output. No validity concern. Wow. Fantastic HSTyle. All right. So now otherwise this CR value should be greater than 0.7. AEVE value should be greater than 0.5. This diagonal values, so this diagonal value should be greater than these three. This diagonal value be greater than this one and this two, and this diagonal value should be greater than this two and this one. This diagonal value should be greater than this one, right? So this is for construct reliability, this is for conversion validity, this is for divergent validity or discriminant validity, right? So now, okay, so now okay, so now if we go here, this is the one, right? Okay, so it's tracking me. Okay, so so desktop, many things are there, right? So sorry. So okay, I'm already using it in another one, right? Let me close here. So now here also calculate estimates. Then so plug in master validity, right? So it will come, right? So all these values, right? Okay, so this is the, I have checked, I have given explanation for CR, AVE and all other things, right? So now is it okay, sir? Second time I have explained, sir.
Thank you very much, sir, for your patience. I'm really impressed. Thank you very much, sir.
Okay, so now this is very important, sir. I thought people know how to draw all these things. That is why I didn't explain. But normally I will explain this validity alone for 2 hours, sir, because this is very important, sir, how to draw, right? Not only that. So if you have any problem, right, see, normally for your collected data, you will not get this result. No, wow will not get. Wow will not get. You will be having trouble. Then you have to remove one item like that, right? Otherwise, you have to increase the samples. Otherwise, you have to remove some items which are creating a problem, right? So that is why if you put a 6 item, we can remove. Now already if you have 4 items, 3 items, if you remove, then right number of items will be reduced, so you'll be having a trouble. So you have to remove one by one. That is the only way out. Okay, so otherwise increasing the samples, right? But I have, okay, I know how the result is coming, right? I know how the value is calculated, how the results are coming. So now whatever the data is given to me, I can bring this result. Okay. So where I should change so that this will come, that is my expertise. That is a different story. But for you, you have to remove each item and you have to improve all these things. That is the only way. So that and all I will explain one by one. So by taking 2 hours. Right. Okay. So fine. Okay, so now, okay, any more doubts, sir?
Sir, is there any relevant sample size is there? Because you said no, it sometimes you have to reduce the sample or increase the sample. Is there any prerequisite that you have to have minimum sample like this for doing this, performing this?
Sir, no, sir. See, even if it is 200, right, I can bring, sir. That is my, this one, sir, my, okay. But okay, there are many views, many rule of thumb are there. So one gentleman, I can give the author quoted by this also, right? He used to say, if it is more than 200, it is fine. Some one author used to say for every item, see for example here we have 20 items, 20 into each item 5, right? 20 into 5 you have to put, right? 20 into 5, how much? So like that you have to put. Okay, so some people they say if it is okay 10 items they will say, but let me tell you one common thing. So I used to take one session on how to determine sample size. Okay, what is the optimum sample size? Right, all the different formula. How I used to derive the formula itself. But leave alone that, sir. But let me tell one final word. So when your sample size is more than 386, you will get the, okay, that is sufficient, sir. Whether you get the, even for 500 samples, sometimes you may not get it. That is a different story, sir. Right. So even for 800 sample, you may not get it. That is a different story. When, right? See, when the data is not proper, otherwise some people they have ticketed just like that. When you have, then all the problem will come, right? If you have genuinely collected, right? If you have more than 386 samples, then right you will get the result. You will get the result. All validities will come. Then you have 5 items or 6 items, right? You remove one item. If or one item, say I talked about the loading, no? If any item is having less than 5, remove that item, right? Any item loading, right? I also know by using, I've got a 0.7, 0.8 like that. Remove items or statement which are having lower loading, then automatically it will be automatically.
Thank you, sir. Thank you.
Okay, so now shall I go to the next one? Any other doubts, sir?
No, sir. Thank you, sir.
Okay. Logeshwari, madam,
Yes, sir.
are you understanding, madam?
Yes, sir. We are following it up, sir.
Okay, so now let me go to another one which I am supposed to have covered on last day. That is called discriminant analysis, right? I personally feel discriminant analysis is not that much useful, right? But as far as I am concerned, yeah, the more important is developing knowledge on regression, right? But all are regression, but on different level we are performing, or for different types of data you are performing, right? But if you have understanding about the regression, right, then your understanding about discriminant analysis will not be a difficult one. Okay, anyhow. Okay, so what is discriminant analysis? Discriminating, right? See, what you mean by discriminating, right? Some people they save more, some people they score more marks. What is the reason, right? Some people they score less marks, right? What is the reason? So now I can tell number of hours studied is the discriminating variable, right? So which means that group studied more number of hours, so scored more marks. So this group studied less number of hours, so they have scored less marks. So the number of hours studied is discriminating or differentiating or making the difference among these groups. That is called discrimination, right? Otherwise, which variable is influencing? In regression, we call it as which variable is influencing, right? So there in a regression, we take our dependent variable is metric. Here, we are going to take our dependent variable is category. That is a group. Yesterday, we had a cluster. No, I told cluster is group, right? So that is a category variable. Otherwise, grouping. So some people yesterday we have classified, right? Then we have come to the conclusion all the variables are discriminating. All the variables are discriminating, right? So now that is the reverse of the discriminant analysis. That is the discriminant analysis, but I will do it in a different way with whatever the output we are going to get. Okay, first let me take a easy example so that you will understand, right? So very easy example let me take. So now I am going to do with the SPSS, right? Discriminant analysis, right? So let me take here also. I think the PPT and all I have already given, right? So now motives. Let me take one. Now. Okay. So now one thing is very important, sir. Very important. What is that? Is you need to know what is category variable, what is metric variable. Otherwise, without knowing that, you cannot do any analysis. You cannot do any analysis, right? So now category variable is here. This is a category variable, right? I have a three groups, right? I have a three groups. So which is a category variable, three categories. That is a category variable, three categories. See, for example, age. So middle age, higher age, like that. Income, middle income, lower income, higher income. Three categories, right? So now, if we have measured, right, otherwise we call it as we have given options, right? That is a category variable. Now another one is a metric variable, whether if you have measured with the 5-point scale or actual data is measured, right? Your income 10,000, 20,000, like that, right? So now here this variable is a category variable. These two are metric variable. Now let me show the data. Here itself I can tell, right? This is a nominal variable. This is a category. This is a metric variable. Scale, right? So this is a nominal, ordinal, or category variable, right? Okay, so now let me go to and show the data. Now see here, this is the category. This is a scale. So this is a mean values, average. Average means mean. Right. Okay, fine. Okay, so let me not go further deep into that. Okay, so if you are not understanding, even if I tell again and again that you may not develop understanding. Okay, so now here I have one category variable, which is a grouping variable, otherwise called a grouping variable, where we have groups, right? Here, two variables are metric variables, otherwise called continuous variable, right? So now my objective is I have three groups, which is discriminating, or otherwise, which is the reason for one people being a higher saver or lower saver or anything, right? So now, okay, now to explain the logic, you need to understand the variables, right? One is called types of motive. Types of motive. One is called self-support motive. Otherwise, I save. Why I save? Because I might leave after my retirement also. So I might require money for that purpose, right? So that is the purpose of me saving. If you have that, that is called self-support motive, right? Some people may be having more, some people may be having less. Another is family-oriented motive, right? So now I save more and more, right? Because I want to leave something to my family, right? So if I am not there, so my wife should not get affected, my children should not get affected. So now for their education, for all other things, right? So that is called a family-oriented motive, right? Now, right? So I got two metric variable. What is the category variable, right? So now I have a category variable which is called this one, right? Where I have one called highly motivated people. Some people they have a high eagerness, right? I classified them into three groups. One is they have a high level of motivation, right? Some people they do not have any motivation to save at all, right? Some people they are having more of self-interest motive, right? So this is the three groups. You can have anything. You can have level of saving maybe one, level of awareness maybe one category, right? Anything, any categorical variable you can take. But you need to explain logically. That is why I have taken this one, right? Okay. Now you have understood the nature of the variable, right? Now my purpose also I have told you clearly. So I want to find out which is discriminating, or which is the reason for one people may be highly motivated, another people may be okay, right? Is it self-support motive making a difference, or family oriented motive making a difference, right? Okay, fine. Now so now analyze, classify here, discriminant analysis. Okay, so now let me put here, right? Okay, fine. So these two are right. These two are independent, right? So now here, okay, now it is here. Okay, it's not coming, right? Discriminant analysis, grouping variable. That is a category variable. The independent variables are metric variables, right? So now I have three groups. So minimum is 1, maximum is 3, right? So why it is asking? Because sometimes your category variable may be having 5 categories. But I do not want to take first category and fifth category. Then you have to put 2 and 4, right? Minimum 2, maximum. Otherwise, if you want to take all the 5, okay, 1 to 5 you can take, or otherwise 3 to 5 you can take. So that option is given to you. That is why different ranges come, right? Okay, fine. Okay, now, okay, so now if I say okay, it will come. If I say okay, it will come. So I have this output, right? So now, before going to this output, okay, so this output, right? Let me go one by one. So first of all, okay, let me do it again, classify, right? Discriminant analysis, right? Here, statistics, right? Unstandardized coefficient, right? Unstandardized coefficient that I want, right? Now save. Let me save this predicted discriminant score, right? Discriminant score. I'm saving right now, which means I will get to the score now. Right? So continue, right? Let me say okay. So now let me say this unstandardized coefficient, right? So this is my unstandardized coefficient, right? So now, right now this table, right? This is similar to regression, right? So you have a value constant, right? Plus beta 1, beta 2, all values are there. So now, okay, so now you can note down these values, motive 1, this one, right? So now let me show this PPT, okay, so that, okay, so same thing written here. Right, what is the data set, all these things, explain how to go, right? All now this is the one, right? Discriminant function. So this is the table you might have noticed. Now let me write a equation. Is that one, that is a discriminant function 1, so this is my beta 0.211 into this is my x. So y is equal to a plus b1x1 plus b2x2, like regression equation I'm writing. So this is my a value. So I put this a value in the end, right? You can put a plus beta 1x1, beta 2x2. Otherwise, beta 1x1 plus beta 2x2 plus a1, a, that is what, right? So I have written this is my right. This is my equation, right? How I got it? I went to the statistics, function, coefficients, and standardized, save discriminant score. That right. So now, okay, now let me show the data set. Let me show. Right. So now you can see, right? Now I got two new values because I've saved, right? My discriminant score is at 1, right? Is at 1 equal to, this is my Z1, this is my Z2. Now y, right? In a regression, we'll put y equal to a plus bx, right? This is my y, this is my Z1 here. Because now since we want to make description, we put a discriminant function. Normally we'll put Z1 and Z2, right? So my this one is Z1, that is this one equal to 6.6, like that, right? Now, okay, so now this is my equation, right? So this is my equation written, right? Now, okay, so so now this is the output, right? Same thing, right? Same thing. Now, see, now I said let me run, right? I've written the regression equation, right? Now let me run. Yeah, now let me run. I know I have shown this is my, okay, so Z1 is my y variable, this is my dependent variable, this is to my independent variable, right? I'm going to run a regression whether I'm getting a result or not. Regression linear. So Z1, let me put Z1 first. Z1, because now these two, right? You can see that 0.2, like that score, right? So you can see See here, 0.212, right? That is the motive fact. Now this is A value is 0.606. So now same thing, right? So when you run the regression also, you are getting 1.9, this 0.212, 0.6, right? So it is a, okay, is that one, that is the, I have run the regression, I have shown also, right? Okay, fine. Now, okay, so now I can tell, okay, now, which means I can derive my dependent variable by using this equation. Right. So now my purpose is to derive the equation, right? I've told you it is like a regression. Okay, I've done. That is the first step. Over. Now, now let me go straight away into our purpose, right? That is what regression output has. So now let me go straight away into my purpose, right? Right. So analyze. Okay. So classify. Right, whatever I have already done, let me remove it. Please do not now you did not watch it, because already otherwise my result will come again and again. Okay, so whatever I have done, I am removing. Right, just remove. Right, just remove. Right. So now okay. So where I am going is okay. So is so in the classify I have, okay, so these are all very interesting results. So let me have the combined plots, right? Territorial map also interesting, but let me not confuse you much. Let us have combined group. This is more important, right? Combined group. So where I meant classify combined group. Now I will get one interesting diagram. Now I will get one interesting diagram, right? So this is my diagram, yeah. This is my diagram. Now you have to read this diagram, right? Now I have function 1. Now I have shown this is my, okay, so, right. So I have shown this is my function 1, right? Function 1, right? This is my function 2, right? Okay, so now I'm going to rewrite my function, leave it now. Okay, now this is my function 1, right? Canonical function 1. This is my, okay, function 2, right? Now this is, otherwise you call in the x-axis I have taken function 1, y-axis I have taken function 2, right? Okay, now what is the function of okay, otherwise what is this graph is simple, yeah. What is this graph is? So this one I have taken in x-axis, this one I have taken in the y-axis. This value I have taken in x-axis, this value I have taken in y-axis. This is function 1, this is function 2. Right, ready? Okay. So now read the function 1. Look at this weakly motivated group in green. Look at this blue. Right. So we have right, weakly motivated people, all these things are category 1, category 2. Now if you look at the scores, these weakly motivated people are lying here. So which means let us draw line from weakly central. This is the center, right? Let me draw a line from here to here. Right? Draw a line from here. So which means these people, they have less level of function 1. Let us look at these people, right? So now let me draw a line. I'm drawing a line, right? So these people, they have a low, these people, they have a high level, right? So now in a function 1, weakly motivated people, they have a less values, less scores. In a function 1, highly motivated people, they have a higher values, right? In a function 1, right, highly motivated people, they have all higher values. Weakly motivated people, they have all lower values, right? Right, fine. Now let us go here. Now there is no much here. If you draw a line from here and there is no much difference between weakly motivated and self-centered. If you draw to function 1, right, draw, right, adjacent. Now, whereas if you go here, function 2, you take these weakly motivated people, let me draw here, they have a low, right? If you look at this one, they are in the middle, but self-centered people, they have high. Okay, now let me tell you again, finally, as weakly motivated people, they have lower value in function 1. Highly motivated people, they have a higher value in function 1, which means the weakly motivated people and highly motivated people, they are different in function 1, right? They are low, they are high, which means the function 1 is discriminating, differentiating weakly motivated people and highly motivated. Otherwise, function 1 is the responsible for these people becoming weakly motivated, these people becoming highly motivated. Otherwise, function 1 is discriminating or differentiating weakly motivated group and highly motivated. So, highly motivated people, they have a higher value, this one, weakly, right? So, function 1 is discriminating weakly motivated, highly motivated. Now, I want to know what is function 1. All right. So, now point 1, weakly motivated people, the function 1 is discriminating weakly motivated and highly motivated. Now, here, function 2 is discriminating weakly motivated and self-centered. Right, here difference. Here there is no much. You don't look at this one, okay, but this axis, right? You have to. So now I want to know what is function 1. Yeah, function 1 consists of what? Right, now let me tell you. Now let me go to the another output, right? Let me go to that output, right? Right, now I got that. I'm going for, right, I'm going for standardized canonical discriminant function. Standardized, right? All right. Now, to write the equation, I have used unstandardized, right? To write the equation, I have used unstandardized. To find out which is more influencing variable, I use standardized, right? So, now look at this one. Function 1, right? Function 1. So what is the coefficient, right? This value into, right? For example, factor 1 is 5. Let us assume that mode fact is 5. 5 into 0.1, right? 5 into 0.1, what will happen? It will become 0.5. Whereas, for this also 5, right? 5 into 0.9, that will become 4.5, right? So this value, right? This value, write the equation, right? If you derive the value for function 1, right? Write the equation, right? The equation. Function 1 equal to 0.113 into mode this one. This is 0.797, right? Since the coefficient is more, right? Coefficient is more, right? Multiply with that value, right? So you will get a higher value. So the values of function 1 is more depending on this one, right? Because this coefficient is more. So function 1 is depending on mode fact, right? So now function 1 is a function of mode fact. What is this mode fact? What is this mode fact 2, right? So let me go to the variable and mode fact 2. What is this mode fact 2? So mode fact 2 is, right, mode fact 2. Mode fact 2 is family oriented motive. Right. So mode fact 2 is family oriented motive. Right. So now this family oriented motive making is the main reason for function 1. Now that is clear. Now, so see, let me tell you again. Right. See the family, this one, right? Family oriented motive is having a higher contribution for function 1. Otherwise, the function 1 is depending on family oriented motive. Now, function 1 is discriminating weakly and highly, which means the family-oriented motive is the reason for dividing the people into weakly motivated and highly motivated. Otherwise, since it is a positive, if people have less family-oriented motive, they are weakly motivated. If they have higher family-oriented motive, which means they are highly motivated. So, whether they are weakly motivated, these two groups discriminated or differentiated because of this family-oriented motive. Simple. Right. Now look at the function 2. Now this is minus small value. This is very, very high value. Right. So 1 into 5, which means exactly 5 is coming. So function 2, right, the main contribution is coming from mode fact 1. What is mode fact 1? So now look at the mode fact 1 is self-support motive. Right. So they have, see, if you have higher level of self-support motive, then function 2 will be higher value. Right. So now what is function 2 discriminating what? Function 2 is a function of self-support motive. Right. Now the function 2 is discriminating what? Discriminating the weakly motivated and self-centered. Right. So if the people, they have less self-support motive, they are weakly motivated. If they have high level of self-support motive, they are called self-centered. So they want to have everything for themselves. Since they have high self-support motive, they are called self-centered. So that is making a difference. So now from this discriminant analysis, we can understand which variable is discriminating the groups. So now family-oriented motive discriminating these two groups, and self-support motive is discriminating between these two. Right. So that is what you need to understand from this. All right. So now right. Okay. So now. Okay, so analyze, right, classify, discriminant analysis, right, classify. Now, right, summary table, right. I'm clicking the classify summary table, right. So now let me go here, right. So now here, total highly motivated people 206. Right. Now, if you predict, see, don't take whatever they have already. Right. So now let me predict, right? Let me predict that values also. There. Okay, let it be here. Let me now. Right. Let me save, right, based on our function. Now, earlier that is the data collected. Now I'm going to classify based on our own prediction. So now the save, okay, already I have said discriminant score. Now let me say predicted group membership. By using this equation, by using this calculation, now we are going to divide the people into 3, right? So now we will divide. Right, now we will divide. So now that is saved. Now let us go and see, right? So now this is the group, predicted group. Now let us see both. So this is the actual group, this is our predicted. All are same, right? See here. But somewhere, some difference may be there, where it is. Now, let me do, okay, so ET has given, but let me do here itself, right? So cross tab, let me put, right? Descriptive statistics, right? Cross tab, right? This is the original classification. So I'm putting, this is our classification, right? What extent percentage also we can put. So otherwise, now see here, this is our own table, right? Okay. So totally highly motivated 206, our classification 203 is right. So only 3 people wrongly classified, right? So this is what exact this one. So same result it is giving. Same result automatically it is giving, but we can do that also. We can do. This is what we have done. This analysis cross table we got it. So this is similar to 206 134, right? Same thing it will do. Same thing it will do, right? So now the exact rightly classified is 98.9%. We are classified rightly, right? Which means by using this equation, if you classify, your classification will be right to the extent of 99%. It is very, very great, very, very great. So that also you can, see. This is called accuracy. We have okay, so specificity, okay, all these things, sensitivity, all these things. That is called. This is otherwise called classification results. This is otherwise called confusion matrix. So how much confusion we have? So our confusion is 1%, 1.1% only. Okay, so this is classification algorithm. Classification. Okay, so other things. Okay, we have it is giving many more output, okay, so I can tell all those things, but now it is over, right? With this we can stop. With this we can stop, because our objective is to find out which variable is making the difference in the groups. So this variable making a difference between this group, that variable making a difference between that two groups, right? So that is what we required. We got it. Now, okay. So now, what are the other output? Okay. So other out, the what I am doing is, right. Whatever output I have, okay. I am drawing and using, right. Okay. How it is coming, all these things. That also I am explaining. Right. So now I have this eigenvalue, right? And I have Wilks lambda table, and I have canonical correlation, right? Okay. So let me explain what is this eigenvalue and what is this. Okay. So okay. Okay. Now what is this eigenvalue, right? Eigenvalue is between the group between difference, right? Between groups, okay, between groups divided by within groups. So now when you say two groups are different, the between groups should be different, right? Because these two groups are different groups, right? So the between difference should be higher. Within group difference should be lower. Okay, among the group there should not be difference, right? But between groups there should be difference. So the eigenvalue is between groups divided by within group difference. Sir, what is this, sir? Oh, how to get it, sir? Right. So now let me do. Right. Let me. So 1 point. Okay. So this is the output. So let me take it to the. Okay. Okay, so now this is the eigenvalue, right? 1.806, right? So this is 5.73. How it is coming? Right? Okay. So now, so between group sum of square, within group sum of squares. What is this here? Okay. Right. If it is required, you can okay, you can understand. Otherwise, whatever I taught, that is sufficient, right? But let me get it. Right? Compare means I'm performing ANOVA, right? Where okay, so now, right? So now this is the one, right? So now this is the one, you got it, right? This is, okay. Okay, so now mean is not necessary, right? Only for centroid, right? So look at this value, right? Between groups, 999, right? First 999.999 to 992.942. Within groups is 549. So eigenvalue is 992 divided by 549, right? So that is what I have displayed. So this is what the result. So 992.942 divided by 549, which is equal to 1.08. For a second one, right, between groups is 3.1, within groups is 5.9, so it is 5. Right. So the function 1 is very, very important function. Function 1 is a very, very important function which is making a large difference, which is making a significant difference, right? Which is making the function 1. Right now we have a two function, right? Function 1 and function 2. Function 1 is a function of family oriented. Function 2 is a function of self-support. Function 1 is making a huge difference, right? So now between groups is higher than the within groups. So function 1 is making a huge difference between the groups. Okay. So now this is about the eigenvalue. This is about the eigenvalue, right? So now canonical correlation. Now canonical correlation. Okay. So canonical correlation, right? The canonical correlation is lambda. The eigenvalue is the lambda. Lambda divided by 1 plus lambda. Square root of lambda divided by 1 plus lambda. Otherwise, the eigenvalue for first function divided by 1 plus eigenvalue, right? So now what will happen, right? So eigenvalue is 1.89 divided by 2.809, right? So now, right, see here, okay, so here also I have placed it, right? So 1.809 divided by 1 plus lambda, so which is equal to 8. So canonical correlation is equal to 8.802, right? So for a second function, so this is the eigenvalue divided by this one, which is equal to, so canonical correlation shows the relationship between, right, each function and the groups, right? So what is the canonical correlation? Canonical correlation indicates the relation between the scores. We have a score, right? We have a score, okay, on the function and the group differences, right? So the scores and the group differences, right? So how it is contributing for the group difference, right? What is the relation between the group differences and the score, right? And that is called the canonical correlation. So now let us go to the Wilks lambda. Wilks lambda is within group difference, within group sum of square divided by total sum of square. Now, within group, among the group, within the group, it should be less, right? So, Wilks lambda should be less and less, right? Because within group, the formula is within group divided by total sum of square. Now, here, now same thing, right? Same table I have put it. So, now within groups is 509 divided by total. Within group divided by total, so which is equal to 0.356. For a second function, 314 divided by 803, right? So which is equal to, right? Sorry, within group, right? Sorry, within group is okay. I have to take 509 here. Within group is 549 divided by 8. Okay, so now 549, same thing. Okay, so now here, just of 1 through 2, 1 and 2 combined. 1 and 2 combined means 1 into 2. So which is equal to 0.26. This into this. So this is for second. So here it is less, this is more. So the function 1 is having a higher contribution in discriminating among the groups. Okay. So now that is the one, right? Otherwise, the Wilks lambda, right, can be measured in another method also, right? Wilks lambda can be measured in another method also. Wilks lambda, this is lambda, capital lambda equal to 1 minus, right, this canonical correlation. 1 minus canonical correlation square, right, here, right, that also. So here we have canonical correlation, where canonical correlation is first 802, right? 802, 604, right? So 802, 604 canonical correlation. 1 minus canonical correlation square into 1 minus this one. So 0.356, same thing. 1 minus this one is 9. Okay, so Wilks lambda is the ratio of within group variability to the total variability. So that is this should be less and less. So it is the inverse, the measure of importance of this function. So eigenvalue and Wilks lambda is measuring the importance of each function. Importance of each function. So like this, you will get one more centroid, right? So all these things I can demonstrate, but not necessarily leave it. Okay, so with this, this is the discriminant analysis. This is the right. Sometimes you will get to the structure matrix also. Right? Structure matrix is the weighted correlation, right? How it is calculated. That is also I have written, but let me not. That is the weighted correlation between the functions. Weighted correlation between the function and the F1 into this values, right? Correlation values, correlation this way. It is also because weighted correlation, how it is correlated. Weighted correlation means one group will be more, one group will be less. So that group into that correlation, right? We are giving weightage of correlation based on number of people in that. That is the structure matrix. If the structure matrix also high, which means okay, so that is making a difference. We can look at it, right? Also, this is the structure matrix. So if we have already decided function 1 is a function of family oriented motive, okay, so this function 2 is a function of self support motive, same result. You will not get two different results when you use the structure matrix as well as the standardized one. So standardized one and this one. Okay, so this is based on pooled within group correlation. Okay, within group correlation. That is what it is. So okay, so with this I will stop. Okay, anything else? If you want to ask, you can ask me now. Right, Madam Logeshwari, Madam.
Yes, sir. Yes, sir.
Any doubt? Anything they can ask, Madam.
Participants, you have any doubt?
Sir, I have SPSS version 22. This AMOS can be taken as what you call plugin, or we have to install separately, sir, to operate what you told just now.
No, sir. Nowadays, the present SPSS versions are available with the AMOS, sir. Okay, so the latest SPSS versions. Okay, so there we have the AMOS also. It is coming automatically with the SPSS. But okay, so we are using the yearly version, sir. First, we have downloaded. We have taken 20. Now 21 we are using, sir. But we have taken the separate software, sir. Separate software. Right? I have not used the software which is coming along with the SPSS. I have not used it, sir.
Okay, that means we have to subscribe separately the AMOS you are saying, sir.
We subscribe, sir. We subscribe. If you want, I will send the software, sir. Use it, sir.
Thank you very much, sir. Thank you very much, sir.
Any other questions, sir? You send your request to your madam so that I will send it to that madam.
Thank you, sir.
So this I cannot give like PPT and other things. Okay, that is given to all. That is my own this one. Okay, my own data. So my own data I am sharing. But for example, for this factor analysis, this EFA I have used to know. This is somebody else's data. They have asked me to analyze. They had a problem with this validity. So they have sent it to me. I have made changes. I have made it to Pakka. That is somebody else's data that I will not give. But my data under all I have given, sir. With that, you can.
Thank you.
Yes, dear participants, you can unmute yourselves and ask questions to sir. I think we are come to the end of the session. Vishnupriya, kindly read out the comments put in the chat box.
Yes, ma'am. Yes, ma'am.
First questions paakattu madam. If there is any question in the comment box, we are like you please read madam. Other comments we will see later.
Sure, sir.
Now, okay. Okay, so now
Good evening, sir.
good evening, madam.
Sir, this is Vidya here, and I'm a scholar in Madras University, sir. My research area is customer perception towards digital marketing, and this is how what to say my research work and field of research is going, sir. So regarding this topic, I expect some valuable inputs from you. How in what way I can bring novelty by applying the techniques that you have taught today, sir.
Madam, that you have to discuss with your guide and you have to
Ah,
bring, madam. See, with respect to how
okay.
analysis can be done, right? So I can give idea that is a different story, madam. Right? That is a different story. But now we are in a group, right? We cannot give ideas to individual. This one, madam. What that is our individual title, right? If whatever I say, it should be applicable to all men. So if you ask that kind of question, then I will tell here. So that whatever question which you are asking, that one to one you can call me later.
Okay, sir. If possible, you can give key areas that I can cover, if possible. Any key points which I can cover, sir.
Okay, okay, okay. Anything else, madam? Anything else? Anybody else? No question? So now,
It is almost time, dear participants.
so
Yes, sir.
somebody
You can
else,
continue, sir.
no, madam. If anybody else on any other question, not exactly related to their own area, right? If you ask any question on anything, you can ask now. Not only related to what we have discussed so far. Anything else also, one or two questions I will take so that we will complete.
There's a question in the chat box.
Mm.
So the question is, they are asking you to share the AMOS, which can be run through SPSS 22, sir.
That I will give it to madam. Oh,
Okay.
yes, sir, madam.
Okay, sir.
That will be available in
Yes,
Drive.
participants, we will send it.
Okay, that will be available in Drive. I will send that Drive to madam. Any other question? So, if there is no questions, then okay, you can proceed, madam.
Yes, Vishnupriya, you can render the vote of thanks.
Yeah, ma'am. Okay. It's not happiness that brings us gratitude, it's gratitude which brings us happiness. Actually, today we had a very beautiful session, sir. Like, we came to know about new things. Like, last session, we learned about factor analysis, and in this session, you very briefly explained about discriminant analysis, sir. Thank you so much for your
Not briefly, madam, detailed explanation, madam. Right? Because no book will tell how the values are coming. Right? If whatever book you read, so they will tell what it is, what is the meaning. But I have explained how the values are coming. I have calculated and I am showing, madam.
Thank you so much, sir. It is a
Thank you so much, sir. Thank you so much, sir. Next opportunity, we have to meet in person for one more session, sir. In person, in house, sir.
Yes, yes. That will be better, madam. Any Saturday, Sunday, you put
Yes.
it, madam. So now the
Sure, sir. Sure, sir. We will go on to the next advanced level, sir.
not
Yes, sir.
advanced level, madam, but from the
Okay.
beginning they have to learn because
Same.
many some people still they do not know what is metric variable, what is category variable. So
Correct.
that understanding they need to have, then only they can use it. Okay, so if you put
Correct.
1 day, 2 day, I can cover some of the interesting sessions, madam.
We will do it, sir. We will
But
do it, sir.
physical
Thank
mood
you.
is
Thank you.
more advantageous, madam, because then only I
Yes,
will
sir.
make the people to listen and I will make the people
Work on
to
the system.
work
Correct.
on that. So now online, I
Correct.
feel it is good, but because you are watching very closely without any disturbance, you are watching closely. But what will happen since it is online? See, you will listen for some time. After some time, somebody will disturb. You will watch that. That even if you go outside this session 1 minute, you will be losing a lot. The
Exactly, sir.
continuity will be missing. That is the great disadvantage of this online. Otherwise,
Yes.
we are seeing closely and telling. Then where I am going, that you may not see, right? If you do, say, you may know, madam, what is my way of doing. I used to ask the people to do, right, on their, they have to put their hand, they have to do. That is my way of teaching
Sir,
and way
in
of.
2012 or 11, I have attended your regular sessions, sir. So I know how you will take care and ensure that we all work it out before we leave the session.
That is what my habit, madam. That is my. I will
Yes,
put
sir.
you all people into pressure. I will ask questions and other things. So finally, they have to learn. My idea is somehow I want to take it to the people, madam. Okay, I want to take it to
Thank
the
you.
people. That is my idea. That is my interest. That is my vision, madam. Okay,
Thank
thank
you.
you,
Thank you,
thank
sir.
you, thank you, thank you, madam.
Thank you.
Thank you, sir.
Thank
Thank
you,
you, sir.
everybody.
Thank you.
Thank you for all for listening,
Thank you.
patient listening.
Thank you.
Thank
Thank you, ma'am. Thank you, sir.
you.
Thank you. Thank you.
Thank you, sir.